Okay, guys, we're doing question 3. Question 3 dealt with an exponential function which they told us was given by the equation f of x is twice a half to the power of x plus 1 plus 3. Now remember, your mother curve for all exponential functions is y is equal to a to the power of x, where a is our base, in this case is a half, and there's our power. So if there's anything in front of the a, it's a vertical stretch of factor 2. If there's anything added to it, it means it's a horizontal translation of the graph 3 units upwards. Okay, first question that they asked us was number A, to write down the equation. Let's look at it. Write down the equation of the asymptote of f for 1 mark. Now you know the asymptotes for the basic exponential curve is the x-axis over here is an asymptote, but that graph was translated 3 units upwards, so this will be the line y equals 3. That's standard basic knowledge of your entry-level transformations. Okay, the second part asks us to calculate the value of a for 3 marks, and a, again, as a reminder, is part of this point over here. So what do I have? That point lies on the function f. So the point is a, which has an x coordinate of a and a y coordinate of 7. So I go to my function, I make all the x's a, and I equate it to 7. I have the equation, all I need to do is that, and then solve for a. So let's quickly see what happens here. Twice a half, don't forget your therefore signs, to the power of a plus 1 plus this 3 is equal to 7. Okay, and that is what I have to work with. I throw my 3 over the equal sign, it becomes a minus 3. So on this side I'll have 7 minus 3, which is 4. And look at this now. Once the 3 is over, I'm now going to divide by 2. So that the 2 also goes to the other side. And I'm left on the left-hand side with a half to the power a plus 1. Now that's an exponential equation that needs solving, folks. And you remind yourself of the exponential law. I have on the right side, I have a 2. On the left side, I need a 2. I can't work with a half. So I apply my law that says 1 over a to the power of m is the same as a to the power of minus m. So in the power, be careful. I put a negative and put a bracket around your powers so that you do not mess up your powers in this case. Okay, it's not minus a plus 1. Some of you forgot to do that and work to the power of minus a plus 1. So now I can ignore the basis. Remember, the power on the right is 1. So I have minus a minus 1 on the left hand side is equal to the 1 on the right hand side. You throw the 1 over to the right hand side, becomes 1 plus 1 is 2. Minus a is 2, so a is indeed equal to negative 2. And there you've got it. So the point A will be the point minus 2 and 7. Okay, so this is the point minus 2 and 7 if we're going to need it later on. Okay, let's look at the last part. For 2 marks, they ask you, they say the point B minus 5 lies on this graph. How must this point be translated for that point to now lie in the origin? Now please, this is all you needed to do, folks. You've got a point there. The point we tell you lies at minus 1 and 5, and we want this point to go through the origin. So it will need to come down a few units and then move to the right a few units. So it's a simple translation. It goes downwards 5, and to the right it will go 1 unit to get to the origin. Okay, so for part C, it's a 2-mark question. So we are going to translate the graph or the point, but we don't need the graph. 5 units downwards the fact that you said it's downwards, it's implied that it's a vertical down, and then 1 unit to the right. And then the point will then go through the origin 0, 0.